I told my mother-in-law, I said, one of my students said, this class is wild. She said, it sounds like you're speaking another language when you're teaching this class. All right, so we've just finished up with question number 5. Let's keep moving. So the next questions will be a little bit, move a little faster here. So um, I'll ask you guys to answer this one. Which of the following substituents will not direct to the ortho-para position? Anybody get this one? Not going to be because this is a halogen, right? Bromine is a halogen, right? And it's a weak deactivator, but it does direct ortho-para. Yeah, it's going to be B, right? When you trihalogenate a methyl group, so we have a strong electron withdrawing group, and so that's going to be a meta director. So if you have, let me just explain this to you. If you have a CX3 group where X is equal to fluorine, chlorine, bromine, or iodine, those are all going to be meta directors, right? They're strong deactivators. All right. So let's move on to number 7. It says, which of the following substituents will direct to the ortho-para, will direct the incoming group to the ortho-para position? Anybody get this one? So we're on question 7. So if we look at A, yeah, so thanks, Audrey. The answer is E, right? Because A is an ortho-para director. It's just a methyl group. C is an ortho-para director when we have a lone pair directly attached to the aromatic ring. And then if you look at this one, we just went over this one. This one's a meta director. And then here we have an ester that's attached by the carbonyl group. And so that would be a meta director as well. Yeah. All right, number 8. Which one of the following substituents will direct the incoming group to the meta position? So if we look at a nitro is strong electron withdrawing group. A nitrile is also a meta director. This one, like we just talked about, is a meta director. And a carboxyl group is a meta director. So the answer to this one would be everything. Everything, thanks, Audrey. Everything would be a meta director. Number 9, which one of the following substituents will not direct to the meta position? So if we go back here, this one is a meta director. This one's meta. This one's meta. And so the answer is the ether, right? The ether is, remember I said that's kind of in between a strong activator and a moderate deactivator. So this is an ortho-para director. Good. Wunderbar. Let's keep on going. It says, give the preferred products of the nitration of bromobenzene. So keep in mind here, that it says products. Okay, so if we had bromobenzene, so let's just pencil in bromobenzene here. Looks a little something like this. So if we were to try to nitrate that with nitric acid and sulfuric acid, all right, where does the bromine direct to? Anybody? Yeah, thanks, Tiana. Ortho and para. So we're going to get a mixture in this case. The para would be the major, wouldn't it? Right, because bromine is a lot bigger than a methyl. So this would be our major product. And then the minor product would have the nitro ortho to the bromo. So we'll put this here and we'll put the nitro group there. So this would be our minor product. Good. All right. The next one, remember we have that ether, which is an ortho-para director, and we're treating it with fuming sulfuric acid. Does anybody remember what type of functional group we would install on the aromatic ring in this case? Does anybody remember yeah, it's a sulfonic acid, exactly. So SO3H. Remember, that's our blocking group. So if you didn't remember, that's what we use this for, is a blocking group. It has other uses as well, but that's a big one. Predict the major product of the following reaction. So here, this group is the ether, so that's going to be an ortho and para director. Para position is blocked. And then we have this ester that's attached by the carbonyl, and so that's a meta director. And so we're going to go ortho to the ether, or meta to the ester, however you want to look at it. And we're going to install this tert-butyl group. So our product is going to look like this. We have our ester up here. So there's our ester. Then we have our ether down here, and we're going to install our tert-butyl group right there. All right. Did I put it in the wrong spot? I did. There we go. That's a little bit better. All right, that's much better. Okay, let's move on from there. Next one says provide the reagents necessary to carry out this conversion. So if we want to put a bromine ortho to this gigantic, right? This is a big old, remember, this is a T-butyl group, and we want to put the bromine ortho to it. What strategy am I going to have to use here? Can anybody remind me of that one? Yeah, thanks, Tiana. Absolutely. I'm gonna need a blocking group. So I'll just abbreviate the tert-butyl. So we put a BU with a T superscript like that, or sometimes we can use just TBU. That might be easier. And so we're going to put the blocking group in first. So we'll put fuming sulfuric acid. That installs our blocking group. So we have our sulfonic acid. Now we're set up to install the bromine. So we'll just put bromine, and we'll use iron 3 bromide as our Lewis acid catalyst. And so that puts the bromine right where we want it. We still have our tert-butyl group up here, and we have our blocking group like this. And then to get here, we're going to use dilute H2SO4, and that will remove the blocking group. And there you have it. Okay, this one. So I told you that this group doesn't show up a whole heck of a lot. But if you remember does anybody remember when you have a positive charge on a nitrogen, is this an ortho, para, or a meta director? You might have to go back to the table 18.1 because I mentioned it last class, but we didn't use this one. If you have a positive charge, think it's going to be pulling electron density out of the ring, right? So what kind of director would this be? If it's yanking electron density away, not donating it, but pulling it away. Exactly. This is going to be a meta director. So it's going to be directing here and here. And then, of course, we have this ether, right? And so the meta director is going to be a strong deactivator. Maybe I should write that down. It's a strong deactivator. And then we have the methoxy group, which is going to direct to the ortho and para positions, but it is a moderate activator. And so it's going to dominate, isn't it? Right? Now, we're not going to get anything going in at the position in between the two groups. And so if we want the ethyl group to go in the ortho position, I don't think we would need a blocking group in this case. You'd still end up getting some of this product. And besides, if you think it's going to go to this position, this group here is larger than OCH3. And so all you would really need to do in this case is just treat it with ethyl chloride and aluminum chloride, and that will give you the desired product. All right, there we go. Oops. Okay, the next one. Doing a nitration and a bromination. Hey, I'll ask you guys, which one of these groups would you install first? And it's not a trick question. Got a nitro, got a bromine. Which one would you throw in first? Yeah, exactly. Thanks, Mary. Absolutely. You definitely put in the nitro because it's a meta director, and the bromine is an ortho-para director. Absolutely. Right, so you'd have to put the nitro in first because that's going to direct the bromine in the correct position. If you put the bromine first, that would put the nitro in the para position. Exactly. Awesome. So I'm just going to write down the reagents in this case. Step 1 would be nitric acid and sulfuric acid mixed together. And then step 2 is just going to be a bromination. So for that, we'll put bromine and my favorite Lewis acid. There we go. Iron 3 bromide. Okay, next one we want to do. So Mary, let me ask you a question. Which one would I install first in this case? And it can be anybody who answers. Would I put the chlorine or the nitro in first in this case? It's going to have to be the chlorine, right? Because the chlorine, right? The chlorine is an ortho-para director. We can't put the nitro in first because it's a meta director, and these two substituents are para to each other, right? So there you go. We're going to put the chlorine in first. So we'll scribble that down. We'll put, let's use aluminum chloride. And then in the second step, we'll do our nitration, which is nitric acid and sulfuric acid mixed together. Like I said last class, you want to make sure you're wearing your old clothes when you're doing that reaction. Messing around with two strong acids. Make sure you have your gloves on, your safety goggles, everything you got. Okay, let's try another question in the same vein. Okay, so in this one, I've got a ketone. So I've got this ketone group, or you could call this an acetyl group if you want, right? What position does an acetyl group direct to? Could anybody tell me what I have in the red circle? Would that direct orthopara or meta? Anybody? No, no. It's going to be a meta director, right? So if you have the carbon, remember, so a carbonyl, right? If we have an acetyl group like this, right? This is electron withdrawing. So usually when it's strongly electron withdrawing, it's usually a meta director. The exception would be the halogens, right? So this is a meta director. Yeah, and then the bromine, as we discussed a few minutes ago, right? That's an ortho-para director. Good. And so in this case, we're going to have to put the acetyl group in first. So we're going to do a Friedel-Crafts acylation. So step one is to use the analogous acid chloride and aluminum chloride like that. And then in the second step, we're going to put bromine and iron 3 bromide. There you go. So you can see how these questions really test your ability to not only remember, what are the reagents, what is the direction of, where's the directing group directing, and what's the order, right? What's the order I have to do the reactions in? So these are good questions, okay? What about this one? Tiana. Yeah, Tiana says, ability to memorize table 18.1. Absolutely, Tiana. I'm not going to argue with you. All right, Tiana, what do I got to do in this one? I want to put two groups ortho to each other. What strategy am I going to need? Yeah, absolutely, right? You need a blocking group. Okay, so my next question is, both of these are ortho-para directors, right? An ethyl group is and a bromine is. Which one would you put in first? There is a correct answer. You'd put the ethyl group in, right? Exactly. Why? Because this is a weak activator. That's right. Right? And then this is a weak deactivator. So you want to put in the activator first, right? Because that's going to improve your reaction yield. So great choice. Okay. Let me just, I don't know if there's enough room here, but we'll give it the old college try. So we're going to start by installing the ethyl group. So we'll use ethyl chloride and aluminum chloride. We'll do our Friedel-Crafts alkylation. So that puts our ethyl group in place. Now we're going to put in our blocking group. So we use fuming sulfuric acid, and that will put our sulfonic acid para to the ethyl group. Just clean that bond up. There we go. So there's our sulfonic acid. Next thing is going to be bromination. So bromine and iron 3 bromide. That's going to put the bromine exactly where we want it. So here, there's our ethyl group, and there's our sulfonic acid. And then to get to the very last part, let me just move this out of the way. Son of a gun. Try this. Yay. There we go. All right, the very last step is that we're going to treat that with dilute H2SO4. And there you have it, a little synthesis of this interesting compound. Okay, next reaction, same or similar vein, I would say. But one thing I want to do with this one is do a little bit of a retrosynthesis, right? Because we didn't see any way to install a carboxyl group directly. Okay, we haven't really covered that. I guess we could with a green yard, but that's not what the topic is here. So I want to use electrophilic aromatic substitution and the reactions that I learned in this chapter. And so, you could make this compound from parachlorotoluene, right? If you have parachlorotoluene, all you have to do is a benzylic oxidation using chromic acid, and that's going to oxidize the methyl group directly to a carboxyl group. All right. So then the question becomes, well, how do we make this compound? And hopefully that's a little bit more straightforward of a problem. What would you put in first, the methyl group or the chlorine? I would put in the methyl because it's an activator and the chlorine is a deactivator. So we're going to start with our aromatic ring. We'll put in our methyl group, so methyl chloride and aluminum chloride. That's going to put the methyl group here or anywhere really, okay? Then we're going to chlorinate it, so we're going to use chlorine and AlCl3. It's not pretty handwriting, but there we go. So there we go, CH3 and Cl. And then to get to the final product, we'll use chromic acid. You could either use the two-step process that we saw a few questions ago, using potassium permanganate and sodium hydroxide and heat, or you can just make chromic acid using sodium dichromate, sulfuric acid, and water. All right, and that will do the exact same thing. Let's see here. Next one. We've got an isopropyl group and we've got a propyl group. All right, and we want to avoid any kind of rearrangements with this one here. Okay, so if we want to avoid any kind of rearrangement, so we'll put here avoid rearrangements. And so because of that, I'm going to use a Friedel-Crafts acylation followed by a Clemmensen reduction. And so really what I want to make is this compound where I have my isopropyl group in place, and then I'll put my 3 carbons, but I'll have them as part of this acyl group here. So I want to do a Friedel-Crafts acylation. So if I have a choice between the isopropyl group or the acyl group, which one of these should I put in first? Could anybody help me out with that? Going to be the acyl group. No, sorry, not the acyl group, right? Because the acyl group is a meta director and the isopropyl group is an ortho para director. So we're going to want to put the isopropyl group first, okay? It's not just about activating, it's about directing too, right? And these two groups are para to each other. So the first thing we'll do is we'll treat it with isopropyl chloride and aluminum chloride. So that would make isopropyl benzene, or cumene as it's called. The next thing we would do is install the acyl group. So again, using Friedel-Crafts acylation. And then the last thing is that crazy reaction that we call the Clemmensen reduction, which is like magic, where you just take zinc and mercury and you just say bye-bye carbonyl kind of thing. So HCl and heat. And there we go. How many more are there? Oh, jeepers. I don't know if we have time to do all these because I got to get into chapter 19. We'll do a few more, see where it takes us. Provide the necessary reagents for this one. Yeah, this one's kind of a tricky one here because really, the only way I can think of to put that nitrile group in there would be to make this compound. So here's my sulfonic acid. And then if I had like the bromide here, then I could do an SN2 with sodium cyanide, and that would just, nucleophilic attack, loss of leaving group. And then if you're wondering, well, how do I make that compound? If you have just the ethyl group in there, right, like this, it's kind of a tough question, right? You could replace one of those benzylic protons using NBS. So you would use N-bromosuccinimide and do a benzylic bromination. So that, it just makes this question a little bit tricky, but so what you would do first is you would put in the ethyl group, then you'd put in the sulfonic acid, and you would do the last 2 steps. Right, so step 1 would be ethyl chloride and aluminum chloride. So that would put your ethyl group in. Step 2 would be fuming H2SO4. That would put your sulfonic acid. Then you would do NBS and heat, and that would install the bromine. And then in the fourth step, you'd use sodium cyanide for that SN2. And the very last step. Kind of a tricky question, that one there. Let's try number 22. This would be a great quiz question. I like this question quite a bit. You take an aromatic ring and you want to put two bromines and an isopropyl group all right next door to each other. So what kind of strategy do we need again? Or favorite in mind? Starts with B, ends with locking. That's right, Maria, a blocking group. Exactly. Okay. So could anybody tell me what group they would install first? What am I going to put on that ring first? The isopropyl group, exactly. So I'm going to use isopropyl chloride and aluminum chloride, and that's going to install my isopropyl group. So let me pencil that in. Right now, I can't do the bromination directly because that would put it in the para position. I want it in the ortho position. So the next thing I need to do is install my blocking group, as everybody told me, and you were all correct. So I'm going to put in my blocking group like so. So there we go. SO3H. So the next two steps are going to be number one. We'll put here excess bromine, since we want to do it twice. Excess bromine and iron 3 bromide. That'll install two bromines. And then the second step to remove the blocking group is going to be dilute sulfuric acid. And there we go. Hot dog, we have a wiener. The whole thing's done. Just like that. I'm going to skip the next one because it's pretty much very, very similar, I would say. This one too, I'll post it. I'll post the answers to this one. Provide the 1 bromo, 3 isobutyl benzene. Post the answers to that. 26, we did that. We did one like that as well. Let's do number 30. Is it number 30 I wanted to do? 20. No, this one here, 28 is one I wanted to try, and then we'll move on to chapter 19 after this. And of course, I'll post the solutions to every single one of these problems. All right, so this one here I thought is a good one because it involves SNAR chemistry, right? We have 4 groups that we want to install, and the only way that we know how to put an ether on a ring is using SNAR. So you have to remember the 3 requirements. You've got to have a good leaving group. It's got to be ortho or para to the electron withdrawing group, right? And then what's the other one? So it's going to be ortho or para. Yeah, then you have to have the strong electron withdrawing group, which I guess we already have on there. And so if we were to do a little retrosynthesis here, what you really need to make is this compound, where you have the nitro group here, you have the 2 bromines here, like this, and then you need to have a leaving group, like a chlorine. I mean, if you put a bromine there, that's fine too. That'll totally work. But with this, we could just do SNAR chemistry, like I said, and that would give us the final product. We just hit it with sodium methoxide. So then the question becomes, well, how do we make that compound that I have drawn in black, right? And the first step is going to be to put in the chlorine, isn't it? Because the chlorine is an ortho-para director. So we're going to take this molecule, we're going to treat it with chlorine and aluminum chloride, and that's going to put, I'll just move this down here. That's going to put our chlorine here, and then we can do a nitration. So we're going to treat this with nitric acid and sulfuric acid. And so we end up with something that looks like this. So here's our chlorine, here's our nitro. And so the nitro is directing to these 2 carbons, and the chlorine is also directing to these 2 carbons. And so all we have to do is treat it with excess bromine in iron 3 bromide. And that's going to put the 2 bromines exactly where we need them. So we have a bromine here. You get a bromine. And you get a bromine. It's just like Oprah's giveaways, right? And then we have the nitro group here. I love Oprah, by the way. She's awesome. And anyhow, so the next thing is we're going to treat it with sodium methoxide. So we'll do sodium methoxide, CH3, and that's it. And that's going to be your SNAR. The only thing I would say here, I kind of noticed this as I was writing it down, is you could actually switch these 2 steps. You could switch this and this. You could swap the order, and you might actually get a better yield, since the ether is a moderate activator, and the chlorine is a moderate deactivator. So it actually might be better. So better to switch those 2. All righty, there we go. Okay, before we